guys. So section 3.4. $18B, this is page 181. Oh, let's see something. I think that might be. So, this one about mountaineering, climbing Mount Everest. That's nothing I'd ever want to do, because there's a lot of failed attempts still laying on the trail up there. If you don't know what I mean, you probably don't want to. So 18A says John Krakauer, part of the balcony, elevation 27,600 feet. He left that point at 7 a.m. He reached the summit, 29,028 feet, at 1:25 p.m. That's pretty damn high up there, right? I mean, a mile is 5280. So this is almost 6 miles, in between 5 and 6 miles. That's crazy. So find his average rate of ascent in feet per minute. Bless you. So that's part A. Part A is not too bad. Your question is about part B, right? Mm-hmm. Part B sounds a little weird. So I want feet per minute. So of course you got to figure out on how many feet did he go, and how many minutes did it take him to do that. Mm-hmm. Right? So how many minutes does that represent? I mean, how many hours does this represent? Let's say.
6.
Yeah, 6 hours and 25 minutes, and I just convert that into minutes. Totally, 6 hours would be how many minutes? Yeah, 60 minutes in an hour times 6, 360 minutes, plus 25 minutes, 385 minutes. And how many feet did he actually climb in that time?
1,420.
Good, 1,420. So we went 1,428 feet in 385 minutes. And you can just divide those to see how many feet per minute he averaged, right? Just an average. Thankfully, I think every now and again he would stop and go, what the hell am I doing? And then just keep going. That's what I would do. Is that cool? That's part A. Part A is pretty straightforward. Now, part B sounds like it'd be horrible or something. Find his average rate of ascent in minutes per foot. Not a unit that we use very often. But I want to go 1 foot, how many minutes did it take him? But to create this, we've already got all the numbers we need. Feet per minute was feet over minutes, so minutes per foot would be minutes over feet. Sorry, I know it took him 385 minutes to go 1,428 feet. Now just divide those.
So you just basically switch
Yeah,
it?
yeah. Why did we do this over this? Why was that cool? Because I want feet per minute. So if I want minutes per foot, I just do minutes over feet.
I gotcha.
Yeah.
But like you can't divide it at foot.
It won't come out.
Yeah.
It won't come out to a whole number, but it'll come out to some decimal, of course. Yeah.
Okay.
Right. So what do you get when you divide those?
0.26, or if you round it, 0.27.
About 0.27 minutes per foot. So it's just over, 0.25 minutes. I'll go with you for a second.
It's 25.
0.25 minutes would be a quarter of a minute. 1 minute is 60 seconds, so a quarter of a minute is 15 seconds. So to go 1 foot, it would take him a little over 15 seconds. You guys with me?
Mm-hmm.
You can leave it like that, though.
Oh, hell yeah. I'm just trying to make that make sense to us. I mean, I don't think in terms of 0.27 minutes all the time, so that's roughly 15 seconds, a little bit over that. Yeah.
Can you do another problem, like a rise over run problem? 'Cause I don't.
Like a rate problem?
Just anything from the homework, like any problem, because I'm having difficulties with that section.
See where's going this a little.
21, I think.
Oh, so that one goes a little bit. That one is use that information to draw a graph, right? Let me see, blah blah blah. So, yeah, 21 is a good problem to look at. Is very cool with this one. I mean, we're just not used to. We're used to thinking of feet per minute, miles an hour. So if you want to kind of relate this real quick, a little example is sort of like this. If I go 160 miles in 2 hours, what's my average speed?
80 miles.
Yeah, miles per hour would be 160 miles for 2 hours. So I'm going 80 miles an hour, right? But you're going to LA is still actually kind of slow. Now, how about hours per mile? So we're kind of the same thing like that. So then I would just set this up the other way around. 2 hours to go 160 miles. So help me out. What's 2 divided by 160?
0.0125.
So 0.01, 25?
Yeah.
Hours per mile. Right, and again, this is kind of like, what the hell is 0.0125 hours? Well, 1 hour would be 60 minutes. So what's 0.0125 times 60? 0.75, yeah. So it's 0.75 minutes per mile. So 3/4 of a minute I go a mile, is what that's trying to say. You guys semi-roughly with me? I mean, I just did basically the same kind of analysis that I did on this problem. Just in a situation that's a little more everyday for us.
Can you
I don't
still write
find
it as 0.0125 hours?
Yeah, that would be the end. That would be it.
So you don't have to convert.
That would be like part A, part B. This is just me trying to put it a little bit closer to something we're used to. If somebody told me, how long until we can leave? 0.0125 hours. I'm like,
That
okay.
one confused me because I was
Try
like,
it.
there's no such thing as 0.27 minutes.
Yes, there is. Of course there is.
Then
But,
I had
but it
somebody
doesn't
explain
make
it to me
sense.
that it's
Yeah.
almost 15 seconds. I was like,
Exactly. Good.
Okay.
It's a little over 1/4 of a minute, which comes out to 15 seconds roughly. Good. Same thing I could do here. 0.75 minutes is 3/4 of a minute, so that would be about 45 seconds. So to go a mile, it would take me 45 seconds going this fast. Yeah.
There's a question that says find the slope in the Y-Intercept, and it has 7x equals 5y. You have to first get the y on one side, right? To find your slope in the. So how would you do it? The 7x equals 5y.
So we that's right about where we left off, I think, yesterday, was explaining why the parts of that work.
Yeah.
So let me go into that, bring that up here again in just a little bit. Yeah. Now the other problem you're talking about, there's a problem that says, in 2006, there's $11 billion of asthma drugs.
what hour is that?
11 billion. Number
Yeah.
21, yeah. $11 billion in asthma drug products. The figure was increasing at a rate of 1.2 billion per year. Good Lord. All right. So this is draw this graph. Draw a linear graph to represent the information. So, thankfully, I don't worry about doing it. This will be in billions. So you can just use the numbers 11, 12. You don't have to put 11 billion and put all the zeros in, right? That would suck. So, I mean, this scale here, it might make sense maybe to do 5, 10, 15, 20. Remember, the scale's got to be consistent. Every tick mark's got to have the same meaning. So now I can find my 11 billion right here. So I started 11 billion, and now, so this is this represents 2006. Let me see if you guys are cool with this. 2006 would be my starting point. So 2007 would be a 1 tick on this. 2, Or you could put 2007, 2008. That's fine. You guys kind of with me still?
Mm-hmm.
Right. So this would be like 2006 here. If it's increasing at a rate of 1.2 billion a year, if I go over 1 year, how much do I have to go up?
1.2.
1.2. So if I go up 1.2, very roughly, there. If I go 2 steps, I should end up going up 2.4 from the original, right?
Yeah.
So that should take me up to closer to 15. So my line starts to look like that. So that captures where I start, and then it's increasing by about 1.2 billion a year. And if you do like that, it doesn't have to be perfect. It doesn't have to be anything like that, because the numbers they give us are not beautiful. But just capture the idea that it's increasing. Get an idea of how much it's increasing by. Yeah.
Instead of you doubled it from 2 years to 2.4, can you just work from each dot?
Of course.
Like,
Of course.
that's-
Yeah.
all right.
Yeah. I just did that just to make sure that I'm in the right place. I'm still below 15 at that point. Yeah. That 1.2 billion per year is a slope, right? And this section is before we really talk about slopes. But now that we have talked about it, we can kind of look back on this. This is the billions. What axis is money here? The y-axis. And the years is the x-axis. So sure enough, if it's changing, increasing by this, this is the change in y and the change in x. That is exactly the slope. Right? That's what we talked about yesterday. If you change x by a little bit, y's got to change by some amount. That's the slope. Cool. Okay. Of course, if this was decreasing by some amount, my line should go down from here. That would make sense then. But this is increasing, so it's going up a little bit over time.
So the graph is the answer?
The graph is the answer. I
Okay.
love it. Okay, maybe. All right. Anything else from homework?
So with rise over run, do I always have to flip it? Or is that on certain
How do you mean
questions?
flip it?
Like what we did for 18? You know how
Oh no,
we
that was
did-
just specific to that problem.
okay,
Yeah.
so it's not always like that?
No.
Okay.
That was just that problem. Wanted to know what is it the other way around.
Okay.
That's not like a standard thing that we do.
Okay.
Nowhere near. I mean, if somebody tells you, miles an hour, you're fine with that. But if they say hours per mile, like, what the hell is that? HPM. How often do you see that? No, MPH I see. I don't see HPM ever. So that's not a very normal thing to do. So it fits into math perfectly.
Okay.
So math doesn't care which way you put it.
Oh, okay.
Yeah, it'll just figure out the number and go from there. Yeah. Any other questions from? Okay, so we're going to get into a little review of what we did last time. So 3-4 was the rates. Last time we did 3-5 and got a little bit into 3-6. So I want you guys to do these couple problems for me just to make sure we're all on the same page. Find these slopes between these points.
What did you say was 3-5 or 3? Oh, 3-5.
Yeah. Give me a little board license where these points are. So I'm trying to put them. Either one of those points is 1.78 or something. So I want to give it to you in graph form. There's a certain way you could do it. You could look at the points and do it the same way we did part B. Since it's already visual, you might as well stick with that. You can use the English reasoning behind slope, rise over run. So if you start at either point, let's start at that point. How much do you rise? 1, 2. Right? So you got to go 1, 2. And how much do you run? 1, 2, 3, 4. So the slope is, if you reduce that 1/2. Anytime you can reduce slope means there must have been an intermediate dude. This reduced form would say go up 1 over 2. See, there's another point that I just didn't put a dot on, right? Cool. Yes, ma'am.
When we do it, do you want us to visually make the line?
Yeah, this would be nice to kind of see the work, to kind of see what you're thinking about. It makes it easier for me to give partial credit, for example, if I see something. Yeah.
So you said like if you do a graph, you want to reduce it because it's possible to
Yeah, always, whenever you get a fraction from almost anything, you want to reduce that thing. Yeah. And it's nice, I just like to show you that when you can reduce a fraction, very often it has physical meaning. It actually means something. All right, so what about part B? What method do I use for part B? Yeah. So you want to use that formula. Yeah, so it doesn't really matter which point you call y1, y2, which one. So you can kind of pick something. Call this one the first point and call this one the second point if you want to or need to. That doesn't really matter. Either way you do it, you'll be fine. Then you just plug and chug. 3 minus 4 over 2. Good. 2 minus negative 1. So you got to be careful. It's going to be a minus because of the formula and a negative because of the number. Sorry. I just love the expressions of your face. But does that make any sense at all? I mean, so I've got to have these negatives here because of the formula. And why does the formula itself make sense? Because how did we figure out this was 2? We saw the difference between how high this one is and how high this one is. So that really is the subtraction, but when we count, we don't think of it as subtraction. But how many numbers between 8 and 10? 8, 9, I can count twice, or I can just do 10 minus 8 is 2. So that's why that subtraction really is the same as this counting. And so here we get negative 1 over 3. Yeah.
So in letter A, could you just take and put the points like you have in letter B?
Exactly. Like I said, you could take, what point is that? That's the point negative 2, negative 1, and that's the point 2, 1. So if you do it like that, you'll get y2 minus y1, 1 minus negative 1 over 2 minus negative 2. 1 plus 1 is 2. 2 plus 2 is 4. Same thing, of course, right? So that's the algebraic method that does the exact same thing that the visual counting method does. Cool. All right. Yes, ma'am.
I got 1 over negative 3.
I like it because you did. Because the other way to do this, I could have called this one x2 y2, and this one x1 y1, and then I would have gotten 4 minus 3 over negative 1 minus 2. So those are the same number, aren't they? They're both negative 1/3. It's just convention to put that, like John's saying, it's convention to put that up top or out front.
Oh, yeah. Right.
Cool. That's the whole purpose of the 2's and the 1's in this crazy formula, is just so you go the same direction. You just chose the other direction, but you went that direction both. On the y's, you went this way in the y's, this way in the x's. For this problem, we just went the other way both times. If you do both, you're going to get the wrong sign. You would get positive 1/3. That would be bad, because this is a negative slope. Now, if I plot those points, my line better end up pointing where? In what direction? Yeah, it should go down. We just figured out this got negative slope. So if we plot the point negative 1, 4, and 2, negative 1, 4, and 2, 3. There's the line through those points. That line would have slope negative 1/3. Right? Down 1, over 3.
And the y-intercept is 3?
Well, y-intercept is a little freaky. Y-intercept is whatever the hell that is. I don't know what that y-intercept is.
0, whatever number.
Yeah. So the y-intercept does not have to be pretty. It's just wherever the line happens to cross the y-axis, and that could be at any number. Yeah. Yes, sir.
Is the Y-intercept used mainly as a reference point to know where you're at?
In most applications, the y-intercept represents your starting position. Because in most applications, this is something like time. So at time 0, in most applications, is where you start, right? And then you go from there. So if I know the y-intercept, I know where to start. So like y-intercept might be the value of my car right when I buy it. And then the slope is like that, maybe. You drive, bye, 1,000 down, 2,000 down, yeah. You guys kind of with me? So for depreciation, that's a really good slope problem. You start somewhere, you depreciate over time, and you say 5 years later, you know, where you at? Yeah.
Can you find the y-intercept without drawing it correct?
Hell yes.
No. I know there's some sort of way.
We're going to do that today.
Oh.
Yeah. Okay. So any questions on those two things? That's basically the two methods we look at in that slope section. Visually and then algebraically. How to get the slope. So we had a really long preview of section 3.6, which is where it tries to tie some of this stuff together. So I try to get you guys to realize why this form tells me so much. It's almost kind of silly that it tells me so much. Just by solving for y, I know all this stuff. So I did an example. I can't remember the specific example. Let's do another one. All right, so given this equation of a line, let's plug some stuff in. Let's plug 0, 1, 2. What do you get when you plug a 0 in for x?
2.
Yeah, negative 3 times 0 is 0. Plus 2 is 2. What do you get when you plug a 1 in? Negative 3 times 1 plus 2. Negative 3 plus 2. Negative 1. What do you get when you plug a 2 in? Negative 3 times 2. Negative 6 plus 2. Negative 4. So let's take a look at what's going on here. The y-intercept is right there, 0, 2.
Going down 3, the slope is going down 3.
I like it. And every time x changes by 1, y goes down by 3. And I can see that number right there, negative 3 over 1, right?
So let's say you had a 3 over 2, x would change by 2.
Yeah, let's try it, all right?
Okay.
So that's the kind of like the first level of this.
Okay.
Let's try a fractional one. Now watch how I'm going to be smart with what I plug in. Every now and again I am smart. So when you plug in a 0, what do you get for y?
0, and then it's 5.
All right, you get a 5. Cool. I'm not going to plug 1 in because that would make 3 halves plus 5. I don't want to deal with it. So let me plug in 2. Do you see why I would pick 2?
Yeah, because it cancels out.
Because it cancels that 2 out in the bottom. So what do you get when you plug a 2 and you get 3 halves times 2 plus 5? Just plug in a 2 right in.
It cancels out.
3 plus 5, 8.
So
So if I plug a 4 in, 3 halves times 4, 2 goes into 4
Twice.
twice. 2 times 3,
6.
6 plus 5, 11.
Right there,
So every step of 2,
goes up by 2 and then by 3.
y goes up by 3. Isn't that exactly what this says?
Yeah.
Mm-hmm.
Run 2, change x by 2, will make y change by 3. So that's why I call this dude the amplifier. It amplifies whatever x's changes are. And that's what y changes by this much of x. This just kind of moves where the y-axis, where the line hits the y-axis.
So as long as you know your first X and Y, you know what your fourth and your fifth, third, your fourth.
Yeah, exactly. Right? So now I can predict what would 6 do. 14. I don't have to do the work anymore. Right? Every step of 2 on the x is going to be a step of 3 on the y. It's got to be. It's a straight line.
After you get your first point from then on, you can just add whatever the fraction is.
Yeah. Exactly.
After you get your first point.
Exactly.
Okay.
Yeah. And that, I really want you, what we just did with this table is exactly what we do when we graph it. Right? We count so much on the x and we count so much on the y. But when we graph it, we put a point there. Yeah.
That guy's just a function.
Yeah, this is a function.
No, like 3 over 2x is the function, it's a function, it's the process, a function.
Well, this piece of it is the slope. And this piece of it here will be the y-intercept.
Yeah, so is your first point your y-intercept?
Yep.
Okay, got it. So no matter what, any problem you do, your first point will be the y-intercept.
Nope.
Nope?
Your first point will always be any point that you actually know.
Okay.
And very often our first point that we know is the y-intercept.
Okay.
But not always. Right? So let me build my way up to that.
All right.
So here, let me give you guys a... can somebody tell me... Or think about this for a second. Don't say anything out loud. What's the y-intercept and the slope? Don't say anything out loud yet. There. Nope. No. Don't say anything out loud yet. All right, now tell me. What's the y-intercept?
2.
Yeah, so get used to putting that as a point,
Oh,
0,
okay.
2. I like it. And the slope,
-4.
-4.
If it's not -4 over 1.
Yes, you could. Any whole number I could put over 1. That's not going to change it, right? And that's another reason why that's a rational number. It's a ratio of whole numbers. And I do that for slope specifically because slope's idea is rise over run. So I can specifically show myself what the bottom is. So I can see how much it's going to run.
Yeah.
So I was going to graph this. The slope, like I said yesterday, the slope is kind of like the guide. It tells you how to get back to the line. It always tells you how to get back to the line. If I start at a point on the line, it will get me back to the line. So I always want to start at a point that I know is on the line. The only point I know so far is on the line is the y-intercept. Let's graph that. So 0, 2 is where?
In the middle up to.
Yeah, so here's 0, 2. And then what's the slope tell me to do from there? Yeah, Mark.
Down 4, to the right one.
Yeah, so it says go down 4, right 1. So down 4, right 1. So there's my line.
So is the negative sign only relevant to the number it's in front of then?
Exactly.
And fractions
Because I
are-
could, remember what we did yesterday was we moved that negative down here. What would that say? Up 4, back 1. If I went up 4, back 1, I'd end up on the line again.
But you'd still be on the same line.
Still on the same line. Which all makes sense. That line, how far does that line go? For freaking ever, right? So I should be able to go up and over and be on the line, or go down and over, down and back. I mean, I should still be able to get back to the line in either direction because it goes forever in either direction, right? And it's straight, so it's always going to have the same rule to get back to it. It's always going to have the same rule. So that slope works all over. How we know so far? Is that?
Counted back from the 2 to get the 4, right? Like to get the negative.
Yeah,
So you
start at
hang
a
out
point
from
on
that
the
point.
line, and that's the only point I know is on the line is the y-intercept. And then use this rule for every step. 4 steps down, you go 1 step over. And I just need 2 points to really make a line. We normally have a third point for a check, but it needs checks. What should be true about this point? What is that point?
1, -2.
1, -2, and what should that point do? Bless you.
It should make a line with the other one.
Plug in.
Be correct.
Yeah, it should work when you plug it in. And sure enough, when you plug a 1 in for x, you get -4 plus 2. -2 comes out for y. So there's always a way to check the point that you get. How we doing?
So I'm kind of looking ahead to like the homework.
Yes.
What if it's a fraction? So your slope is by a third, and the y-intercept is 0 and 2.
5/3 it would just be
Say, so this is a fraction also. So if I would have made that a 3, the only difference would have been I would have went down for
Right,
over 3. See, in that sense, fractions for slope are no big problem at all. Because no matter if it's a fraction, who cares? Because it's still a number over a number that's exactly what I want for slope, right?
Rise over run.
What really sucks is if the y-intercept is a fraction. Let's not go there yet. Because like I just said, the y-intercept could be any damn thing. We'll deal with that in a bit. We can deal with it now. What the hell? Come on, Jeff. Let's try one. Everybody got this here? All right. So what if I had... yeah.
You want to do some,
Gross. Second?
you are on the point,
Nope. We're going to do the y-intercept and then the slope. So I'll be very specific on a test. I'll say create a table of values to do this problem. I'll say find the slope of y-intercept. So you can put the y-intercept in and do the slope to find the line. So I'll try to be specific about what method I want you to use. But in general, if I ask you to graph this line, you're going to think slope y-intercept. That's the quickest way to do it. Yeah.
Would you just multiply it to make it a whole number?
No.
The y-intercept?
The minute you multiply this, it's not in the right form anymore.
it would be 2y.
You have to have y by itself. So if I doubled everything, I've got 2y. That's not y equals mx plus b anymore. You guys with me? So a lot of people kind of stop. They get to this point maybe. Well, it would be what? And they stop because they don't want to lose their whole number. But then this is not the right form. There's not a damn rule at all. It says 2y equals something. It says y equals mx plus b. So you have to take that next step and solve for y, right? What is the slope here? You have 5 over 3. It's the thing in front of the x. And the y-intercept? 0, -3/2. Cool. What is -3/2? As a mixed number?
1.5, right?
Yeah, -1.5. So we can find that pretty easily. That's not a horrible fraction to have. I mean, if I gave you like 7/11ths, that would be disgusting. It's pretty damn hard to find that. But 1.5 is not bad. So there's -1, there's -2. Where's -1.5?
In between.
What am I doing there?
-1 and 2 on the y.
Yeah, it's going to be in between what? Yeah, -1 and -2. That's where -1.5 is going to be. So I'm doing the same exact process. I have to plot my y-intercept, the exact same thing we just did. I've got to plot this y-intercept, and then I can count up 5 over 3, right? Bless you. So if I'm given a fractional y-intercept, think about it in terms of mixed numbers. It's easier to find. So that'll be 1.5. 1.5 will, of course, be halfway in between 1 and 2. So it's right there. And now when you count, you just count to the half point, So what do I mean by that? Up 5. 1, 2, 3, 4, 5. Is that cool? Because the whole one up would be there. And then over 3. 1, 2, 3. Cool. So that's probably the most disgusting one of those we'll see for right now. Obviously, they can get more disgusting than that. Yeah.
So if it was like 23 over 13 or something really bad, you would just put it in the decimal form and
approximate.
approximate
Yeah.
no matter what the fraction.
So wherever you end up, if you end up, oh crap, what the hell is that? If you end up right here,
Yeah.
then you take 1, 2, maybe 3, and then you just put it right in the same kind of spot as you count up whole numbers. So it's not that evil. It is evil when you're first learning it.
So you're
But
just
in
taking-
general, it's not that evil of a thing. Yeah.
So you're just taking it from a fraction and putting it into a decimal. If you're
Especially when it gets really, really, really bad. I mean, if this is 111 over 78, screw that. I'm dividing that thing and then just approximating where it is. Right? Yeah. Oh, you good? Okay. So, yeah.
Is the slope always the number in front of the x?
Beautiful. So it's even if I had it written like this, 7 minus 2x.
It's 2 and negative 2.
Everybody always makes a mistake and says that's the slope. No, it ain't. It's the number in front of the x. Negative 2. Slope here would be negative 2. The y-intercept would be 0.7. Just because I turn these around doesn't magically change anything. But I want to make that point now because everybody thinks the first number I see is this. No. It's the number with the x. So always try to write it in this form so you don't make that mistake. So you guys try this one. Find the slope and the y-intercept and then graph it. Yep, negative 1/4. Is that too close? It's too close. Yeah.
Are you gonna give back some of the homework?
That you turned in on the day of the test?
Yeah.
Eventually, yeah. And of course, I'm just happy I finished grading the test for my morning class. So this weekend I'll catch up on some homework. Yeah. So what's the y-intercept?
0.03.
And the slope is. So I would fall 1, go over 4. So 0.3, where's that?
Middle.
Yeah, straight up 3. Does it not go over at all?
No.
And then this tells me to go down 1 over 4. But I could also look at this as that, right?
Yeah.
which would be go up 1, back 4. So that's the same line here, isn't it? Oh. I should make that big. That is, of course, completely straight. Yeah.
Why are you not going down 1 left 4?
Because they don't have a negative on both the top and the bottom. Only one of these can be negative at a time. If they were both negative, the negatives would cancel.
So you pick one that's negative.
Exactly. One of them at a time. And you don't have to go both ways, right? You just go one way. But just to show you, if you went the other way, it would still be the same line. Yeah.
Does Y-intercept always have a 0 there?
Definitely.
Before the
Yeah, if this was anything other than 0, I would not be on the y-axis. Does that make sense? So that to be the y-intercept, it's got to be 0, comma something. That forces me to stay on the y-axis.
And it makes no difference with the 1 or the 4, you pick a negative or whatever.
Yep. Makes no difference.
Because the other way that you did there, it would be if you did down 1 over 4, or like negative 4.
Yeah, down 1 over 4, up 1, back 4.
Oh, okay.
Yeah.
What about when it asks you for the slope and y-intercept and it doesn't give you an x?
Okay, good. So we have two things. I want to get to John's question from earlier, and then Andrew's question from right now. So let's see. So John, your question was
7x equals 5y, and identify the slope and the y-intercept.
7x equals
5y.
5y. So somebody tell me, why can't I tell what the slope or y-intercept is yet? Good. The y is not by itself yet. How do I get the y by itself? Yeah, divide by 5. So you get 7 over 5x equals y. Let me just turn this around so it looks a little bit more like y equals mx plus b. Now what else is kind of wrong but not really? Y equals mx plus b. What must b be? 0. Right? So I already know the y-intercept is... What's the y-intercept? 0, 0. So this goes through the origin, right? And what's the slope? 7/5. Up 7 over 5.
Wait, where'd you find? Oh.
So if nothing's there, there must be like an understood plus 0.
Yeah.
Just like, if I have an x and there's an understood 1 there. If you want to go further, there's also an understood plus 0 there, right? I can add 0 to anything. In this case, it just kind of completes the format, right? So the y-intercept must be 0, 0. The slope, of course, is the number in front of the x, 7/5. How we doing? Cool.
But you started at just the 7x equals 5y, right?
Exactly. And I know how to see the slope in the y-intercept is to solve for the y. Because that forces it into this form. So let me do one more like that before I get to your question.
So in this class, we assume it's 0, or in any like math. But if you were trying to find the slope of something and you just didn't have a y-intercept, you couldn't use that at all, because it could be that slope can apply to anywhere, right? The 7 over 5. Like if we were using a graph to graph info, if you don't have the y-intercept, you can't just assume it's 0, right?
So if they only give me a slope, you're right, I can't graph a line because I need some starting point.
Yeah.
Right?
Okay.
Is that cool?
Yeah.
Because if I know a slope of a line is 2, well, where the hell is it? I don't know until they give me a point, and then I know where to put it. But this equation gives me a y-intercept. It does. The y-intercept is 0. Right? So it's not that there isn't one there. It's not that we assume. We know it's 0 because it's the only thing that could be there. So poor little 0 dude is the only guy that wouldn't show up. Plus 1 would show up, plus 2 would show up. Plus 0, we don't keep him around. A little unfair. So, but for the format, we bring him back in. We're like, oh yeah, plus 0 is it.
Is it acceptable to read out the 0 though, or would you?
Hell yeah.
Okay.
But you just got to realize, I always get people that get confused. They're like, they didn't give me any y-intercept. Yes, they did. It's the 0 that's understood to be there.
Because that's also a point on your graph.
Exactly. 0, 0 is a valid
That
point.
is your point.
It's a valid point on the graph. It just wouldn't show up in the equation. Because algebra would go, yeah, it's 0. What the hell? I don't need that shit. And we go, yeah, we do. Yeah.
So there's just like -3, you just go down.
That's right. So if the slope is -3, but be careful. So what's your full question is, if I had something like this, right? Slope would officially, it wouldn't just be go down 3 and that's it. Because what is this over? It's not over 0. That would be undefined. It's over 1, understood to be over 1.
Over 1 to the right.
Good, so I would start at -4 and go down 3 over 1. Yep. So what about this dude?
Subtract the 2x.
Yeah, to find the slope and the y-intercept, what do I have to do? Get y by itself. That forces it into this form. So yeah, let's start doing that. So yeah, I'm going to force this dude in here. Just to put him more in the right form. Is that cool? Let you guys absorb that.
Yeah, that's great.
I mean, if you write 15 minus 2x, you're not wrong. It's just easier to make mistakes. So I'm going to force that -2x in front, where the mx is in the format. So I can see it better. Is that no good? You don't like that?
Okay, because it's not like terms you can't subtract it. So you
Definitely.
Have to add it all
Now, I
there.
could. There's really nothing wrong with writing this, because that's what 15 minus 2x is. But it's getting away from this exact format. And, I mean, let me kind of do this both at once. What would I do next?
So like -3?
Divide by -3. So here I get y equals... Good, the negatives cancel. Yeah, -5 is a negative. Over here, if I divide by -3, I get y equals -5 plus 2/3 x. These really are the same exact thing, it's just that's in reverse, but the big mistake is, again, people tell me the slope is -5, and the y-intercept is 2/3. Because they don't understand the real thing here is the slope is with the x. The y-intercept is by itself. So if it's out of order, it really doesn't matter. So the slope here would be 2/3. And the y-intercept would be the number by itself, the -5. Cool. Yeah.
What about in the notes it just says x equal -1?
Oh, good. All right, so now that's Andrew's question. Right? What if there's a letter missing?
Yeah.
Yeah.
Wait, don't erase it.
So you guys remind me. X equal -1. What kind of graph is that? Remember, that's a special case. Good. Jeremy's got the sliding the home signal going on. Right? It would be a straight up and down line. Because x must stay -1. The only way to do that is to stay right. It can't go left or right. What kind of slope is that? Infinite or undefined, either way. So x equals will always have an infinite slope. The one that makes a little more sense actually is y equals. If I have, let's say, infinite or undefined slope. If I have y equals 2, what kind of line will that be? Yeah, y must stay at 2, so it can't go up or down from there, so it's got to be a horizontal line. And think about this. Put it in the mx plus b form. What must be in front of x, since there is no x? 0. I love it. So this really could look like 0x plus 2. So it makes sense the slope is 0. That's what number's there, right? And a flat line should have 0 slope. Not no slope, be careful, it's 0 slope.
Because you're not increasing or decreasing.
Beautiful. You're staying steady, flat, right? So the slope would equal 0. How are we doing? This is a little harder to understand. There's not even a y to solve for here. That's why it's a freaky situation. I can't get y by itself, so the slope is undefined. It's infinite. I can't get it. Yep.
I'm stuck on an equation, so y minus 3 equals 5. Would I...
So y minus 3 equals 5. Solve for y.
Right.
So then it's a line like this. So the slope would be 0.
Oh.
So if it's missing the x, slope is 0. If it's missing the y, slope is undefined or infinite.
I don't understand that part.
Which part?
That that -1 is your x.
Yep.
Oh, it's negative. Oh, and y this way.
Yeah, and the y could be anything, right? So it goes. It has to stay at -1 for x. It can't go left or right at all. So the only way it can go is straight up and down, because y can do whatever the hell it wants to. All right. Yeah.
It's undefined or infinite because there is a slope. You just can't determine it because there's no run to base it off of, right?
Yeah. I mean, I'll come back to that in a minute when we talk about parallel and perpendicular, which we'll actually talk about right now.
Let's take a break. Mine just.
Where are we at? 2 o'clock?
Oh.
Do you want a break already?
This is like super overload for me. I'm like tired of coffee. Like, how are we not going to make coffee?
Tired. Let me finish up 3-6 and then we'll take a break. All right. Let me at least get one section under our belt here.
I want to skip the rest of the class. I just thought I want a break.
Okay. All right. Here we go. A beautiful map of the school.
No coffee,
I just think I'm just going to coffee. There's some.
so you have to coffee.
Yeah, it's not like driving.
So anything must be true about two parallel lines.
Yeah, both
You
run.
can cross.
They can't cross. I love it.
Right. They go forever.
They have to stay the same distance apart. Now talk in terms of slopes and stuff. They have to have the same slope. If one is going up or down faster than the other one, then that means they're going to have to cross somewhere. They have to be changing at the same rate. They have to be going up or down at the same rate. They have to have the same slope. So if I had two lines, line 1 and line 2, are parallel, and line 1 has a slope of 1/4, line 2 has to have a slope of 1/4. How are we doing? Is that cool? So that should make some sense. If they're parallel, they have to have exactly the same slope, or else one's going to run into the other one. Okay, cool. What about perpendicular? What does that mean, perpendicular? It doesn't just mean they hit. It means
90-degree angle.
beautiful. It means that they hit and they make a 90-degree angle perfectly. That, in a way, that's almost the exact opposite of parallel. They run counter to each other in this case, not across from each other. So this makes a 90-degree angle. And let me try to make this make some sense. Of course, that's what I always try to do. Now go with me here. If I have this line here, what's that line's slope?
1/3.
Yeah, this slope would be up 1/3. Is that cool? Oh, line 1. So the first slope is 1/3. Now, in order to have a perpendicular, at least the slope, a perpendicular line has to have what kind of slope? To be perpendicular, it's got to be negative, right? At least. You guys with me?
Yeah.
So it kind of makes sense. They definitely have to have different signs. If that one's positive, that one's got to be negative to have a chance to be perpendicular, right? But here's the problem. If I just make it exactly -1/3, and I know, understanding that my pictures are nowhere near perfect, but hopefully I've done this well enough. If I make it -1/3, then that would be down 1/3. Does that look like it's possibly perpendicular? I mean, how big is that? I mean, look at that big ass angle there. There's no way. It's supposed to be 90. Does it make sense that they can't just be the opposite sign? So here's what I love. Parallel, exactly the same. Perpendicular, completely opposite. And how many ideas of opposite do we have in mathematics? We have the different sign, reciprocal. So if one is 1/3, the other one has to be -3. Change the sign, reciprocate. So if I make it -3, go with me now. So that would mean go down 3/1. that looks a lot more perpendicular, does it not? So parallel, completely the same. Perpendicular, completely opposite.
So you change both the slope and
The sign
the sign
and reciprocate.
and reciprocate.
You do both ideas of opposites, right?
So it's,
So tell me this. Are these two lines parallel, perpendicular, or neither?
What's that? Oh, that's the second.
You say neither. I say neither. So yeah, these would be, however you pronounce that word.
neither, neither, nor.
I love it.
Oh.
Right? They're not. Why are they not perpendicular?
So it would have to be negative.
Yeah. What if one have to be negative? Right?
It doesn't matter if the top or bottom's negative still.
Doesn't matter as long as if one's got to be positive, the other's got to be negative, and reciprocals. So how would I make? So if I give you one equation, y equals 1/5 x minus 7, what's an equation that would be perpendicular?
Negative 5.
Good. Negative 5x plus whatever. Or, whatever. You guys with me?
Yes.
Y-intercept doesn't really matter. It just moves it along there.
So if you asked us on the test and we saw that, like we just saw 1/5 and negative 5x, you could go with right away. But
Yeah, you can tell right now. You can say, oh, they're negative reciprocals, perpendicular. I get tired right now.
Vice versa, right? You have a negative, since you have a negative whole number.
Exactly. I mean, as long as they have different signs and they are reciprocals. Right? And parallels is too easy. I mean, parallel, if I put 1/5 there, this better be 1/5 also. Right?
So if it was negative 1/5, it would be negative 1/5.
It would, no,
Or,
well,
sorry, 5.
5. Exactly. I like it. Is that cool?
Wait,
So again, if I had a line that was negative 1/5 x, to be perpendicular, this one would have to be positive 5.
yeah, but what she just said, the line's parallel, right? And
No, I think you were talking about perpendicular.
perpendicular.
Yeah.
Oh, okay. But you could totally say that a parallel line would be 1/5 x and negative 1/5.
Well, and again, to be parallel, they have to be exactly the same.
Oh, exactly.
That's all. Exactly the same. Yeah. Yeah.
Where is the 4 coming from?
That's just the Y.
Yeah, I don't really have to put anything there, but does the Y-intercept really care? Does it matter? I really want you to understand. I could have a slope of 2, and this is the Y-intercept. I change the Y-intercept, it's parallel because it has the same slope. The Y-intercept just places it. So I have a line, I can pick it up and move it, and I don't change the slope at all, right? If I have a perpendicular line, if I move this line, who cares? They're still going to be perpendicular to each other, right?
So just looking for the number flip in front of the X.
Yeah, all I care about is their slopes, right? Because lines go forever. Who cares where they actually hit, as long as they hit at a 90-degree angle? So if I have one line here, how many perpendicular lines are there? Infinite number, right? Those are all perpendicular. Okay, hopeful. That's why the Y-intercept doesn't matter. That just moves it around. Who cares? They have to have the right rate of change. As long as one is positive, the other one is negative, and they're reciprocals, they are perpendicular.
So then the first one up there, there's no negative, so it would be...
Beautiful. That's 90. So that's not parallel or perpendicular, right? So don't get caught in the trap that you think it's got to be one or the other one. You got a whole slew of freaking lines that are neither one. They can meet at a 20-degree angle, right? A 10-degree angle, whatever. Okay, hopeful. Okay. So one last thing in this section here. And then we'll take a break. So, if you've never seen this kind of problem, it's sort of, just to preface this, it's one of the problems that people don't like, right? And you're all like, that's every single thing you've said so far, Jeff. But the ones that start with find the equation of the line that does stuff, right? So let me start us off with a kind of a nice one. We'll do 2 of these kind of problems, then we'll take a break. Find the equation of the line that goes through, spelling O, there it is, goes through 1, 4, and 0, 2. Now, what do you need for the equation of a line? You need 2 things. Slope, I agree with you. You need slope. What else do you need? Y-intercept. So the Y-intercept, do we know it?
Yeah, it's right there.
I love it. I love that. It's right there. So what is the Y-intercept?
It's either one.
Careful now. Careful.
No?
The Y-intercept specifically is the one
Yeah.
that X is 0. I love it. So you can't use this dude. It's got to be this guy. 0, 2. So what's B going to be? 2. Sweet. So we have one of our MB things known now. We know B is 2 because that's the Y-intercept. And that's what B is. So, of course, later we're going to talk about, well, what the hell we would do if they didn't give me this thing. And that's related to the question I had earlier about, is there a way to find a Y-intercept without graphing the damn thing? Yes, there is.
Can't you just plot those 2 and then do some common sense?
I like that. Well, how do you mean, though?
So you plot 1, 4, then you plot 0, 2, then you make a straight line, and you find the Y-intercept.
You just connect and count.
Well, in this case, the Y-intercept is staring me in the face.
Yeah. So
And you got to be careful. If I plot 2 points and I go like this, let's say these are the 2 points. It's not always easy to just see what that is, the Y-intercept. Do you see what I'm saying? Because again, what could the Y-intercept be? Any real number. Not just a fraction. It could be even worse. The Y-intercept could be square root of 7. I don't want to deal with that. But I like what you're thinking, though. Sometimes you can just see what it is. Sometimes it will be nice. Not all the time, though. So I'm trying to give a more general way to do it. In this specific problem, the Y-intercept is right there.
And we know that because there's a 0.
Because there's a 0 for X. I love it.
But you can always find the slope with 2 points.
It's beautiful.
You just plot them and count.
But I don't even have to plot it for that, do I? How do I find the slope? Because that's the thing I'm missing, right? I don't know what the slope is. So how do I find that?
Why does B equal 2?
Because the Y-intercept is 0, 2. So what do we keep doing? What's the Y-intercept here? What's the Y-intercept here?
4.
0, 4. Because B is 4, right? You with me? So now work backwards. If they told me that it was 0, 2, what's B going to be? 2. That's what would be there to lead me to a 0, 2 Y-intercept. Is that cool? We were doing these earlier. If I give you y equals 1/3 x minus 1, what's the Y-intercept? 0, negative 1. So think the other way. If I said it goes through 0, 2, what's B? 2. Just going the other way. How do we get the slope? Yeah, y2 minus y1. x2 minus x1. See, so this section is the one that just kind of brings all the stuff we've been talking about, brings it all together. Right? So now we got 2 minus 4 over 0 minus 1. Negative 2 over negative 1. So positive 2. And now you just have to put that together. Y equals mx plus b. What's m? 2. And what's b? 2. They won't always be the same. Just happen to happen. Anytime I have a problem that brings a lot of different ideas together, it's going to be difficult. Each piece of this problem was easy. It's just that the whole problem has many pieces. That's what makes it difficult. All right, so let's take a break. John, you have a... Because they told me. They being me. I gave you the Y-intercept. X is 0. All right, so let's come back at 2:25. I'll give you 15 minutes.
I'm gonna go buy this that book right now. So where it's this book. I just want to look at the price of it. Google Math 90 and it'll be in the bookstore.
Yep.
And I turned in the level switch.
Oh, I forgot to bring it with me. I was going to give you the test from the other class, but
Oh, can I grab it afterwards? And then
actually, let me run and get it because I might not go to my office after.
and then I need to I'm gonna email you tonight with a reminder about that the letter.
Yeah.